Part 1. How to use the program module. Here I will be walking you through the code by which the best fit regression model is construed. First, data acquisition was completed by virtue of downloading the concrete spreadsheet. This was the first hurdle wherein the provided Excel spreadsheet was given in .xls format, a format not readable by the pandas function, and not often used after the release of Microsoft Excel 2007, that used the .xlsx format. This problem was solved by opening the file in Excel and simply converting it to the correct format that can be read easily by the pandas function shown right here. After reading the file, it was converted into a pandas data frame, and the initial data analysis was run on the entirety of the dataset using the various functions shown. Here we have the .head, .describe, .info, and visualization using pair plot. After the initial data analysis, a deeper developed analysis was done within a cleaned up data frame. The data frame was checked for null numbers across the spread, correlation between different qualities of the dataset using a heat map, and 3 scatter plots of the concrete qualities bearing the most intense correlation. So here we have the cleaned up dataset, right? Checking for null values. Here we have the heat map. Here we're creating different variables so that we may plot them. The different plots. The 3 strongest correlated values have been plotted. Under analysis, it became evident that the strength of the concrete is in mild correlation with the amount of cement used during fabrication of said concrete. Fly ash, a substitute material to use excess coal from the coal industry to not only reuse the valuable natural resource but also making use of a separate industry's byproduct to reduce cost of fabrication, is in even milder correlation with the amount of superplasticizer used. This is because fly ash is merely a substitute material, and if it was the best at increasing the strength of concrete, we'd be using it instead of cement. Therefore, the use of superplasticizers is warranted to increase the strength of the concrete further. Furthermore, the third largest correlation in the dataset, albeit still a mild one, of 0.37 is that of the amount of superplasticizer used and the concrete compressive strength. After data analysis, construction of the best prediction model was undergone. Here, the independent qualities of concrete, wherein concrete quality is dependent, are put into its own dataset defined in code by X right here. These qualities are cement, fly ash, water, superplasticizer, coarse aggregate, fine aggregate, and age of the concrete. The dependent quality, that which is dependent on the values of the other qualities of the concrete, is the strength of the concrete. This quality is stored in its own dataset Y. We have it right here. After splitting the data, it was scaled using the transform function shown. This one right here. Following this was the train test split of the data. We have it labeled right here. Finally, linear regression is performed, followed by the plot of the training and test set respectively. Also output is the MSE and RMSE of the linear regression for later reference and comparison. At the bottom of the cell is the creation of a new data frame wherein the predicted values of the concrete compressive strength are compared to the original values side by side. We have that creation done right here at the bottom of the cell. And here in the output, we have the linear model coefficient and the linear model intercept and the plots. Here we have the MSE and RMSE. and the comparison data frame. The following cell is a result of lazy yet intelligent adaptation. Here, the random choice is run and then variables are equated such that the second half of the code is compatible with the first. This is a result of the two parts being written at different times but fixed simply in these 5 lines of code. These right here. The links of the sets are printed to the output for reference by the user. Next is the inclusion of rigid and lasso regression techniques so as to perhaps find a better regression than that of the linear. Printed to the output is the MSE and MRSE. This is followed by a plot of the original versus predicted values given by said regression. So here we have the MSE and RMSE of the ridge and lasso, and here we also have the plot with the regression line plotted right here as well. Finally, we arrive at random forest regression. In 3 short lines of code, this regression technique is accomplished, and in the following cell is the creation of the comparison data frame as well as the MSE and RMSE, which shows that random forest was the best fit regression model for this task. So here we have the comparison data frame with its output, as you can see, and here's the MSE and RMSE printed out right here, and here's signing off. Part 2, Project Management. Both members of this group worked on the final coding project and were endowed with respective aspects of said project. Rigo Alvarez managed the project and broke the project down into its main components: the literature report, exploratory data analysis, and building a best fit model, making that model such that it can accept user input, the project management video, and the model video. Of these tasks, Rigo is responsible for data acquisition and using various exploratory analysis techniques to gather general and important information about the concrete data. By doing so, also using different regression techniques like that of random forests. Every different technique having their respected MSE and RMSE values to display accuracy not only in the numbers but within the different techniques used as well. By effectively taking a role in the order of operations, Rigo undertook the project management video and the project model video, hence being head of project management. Wande is too tasked with the project model video, as we will have both built the code together and hence needed by which the code can be explained in this video. Ezekiel is also assigned to complete the user input and update interface model by using the completed best fit regression model handed off by Rigo and modifying it by adding a user input interface by which can be used to input values of a user and then give a predicted compressive strength for each concrete mixture while also automatically updating itself. In addition to this, Ezekiel completed the literature report. Here our tentative schedule is shown, also put in our interim report. You can see the different dates and what was to be done. And directly below that is the literature report done by Ezekiel. This is the entirety of it. Here is the full list of tasks that the team was assigned. Everything highlighted in green was completed by Rigo, whereas everything highlighted in yellow was completed by Ezekiel. Everything highlighted in red is a major task that, as explained earlier, was worked on by both members of the design team. Although that was not necessarily the case as, for example, Ezekiel did not complete his portion of the module design in time for submission, despite warnings and assertions by project management. You can see that the model building task highlighted in red, while the subtasks involved in said model building are highlighted in green or yellow respectively. Yet only the tasks highlighted in green were completed for project submission.